So what we wanted to do with DocBot is keep patient safety at the forefront, right? So what we envision is that chat interfaces, asynchronous communication, is going to be, the way forward. While consults will obviously happen over video and voice, all follow up, is going to happen over asynchronous, kind of chat communication that everyone is so used to, right? So your text, your SMS, your WhatsApp, your Slacks, and so forth. So while that's going to happen, what we want to do is make that chat interface our kind of unified, patient portal, or the doctor's portal, if you want to call it. And what we envision is all communication, then follow-up communication happening over that chat interface. And then what we'll show you is how what we built actually keeps patient safety at the forefront. It also breaks down a lot of communication barriers, right? So what we built is, has real-time language translation. So when I started talking, we were talking about, how the global healthcare scenario, is so skewed in the sense that, where we need the most doctors, we have the least, and where we don't, we have the most. So how do we kind of balance that out? So, if you're going to have doctors in different geographies, different countries, treating patients elsewhere, language is going to come up as a barrier, right? So how do you break that down? And I'll show you how we do that in DocBot. We're also going to see how we get past barriers of low bandwidth. I mean, if I was being disconnected because of low bandwidth, that's reason enough. And we're going to see how we break down barriers of literacy. We're going to see maybe patients that could be less or a little technologically challenged, or less tech savvy in general, on how we can kind of get them into the system, how to make healthcare more accessible and affordable to them. And then most importantly, we're going to see how we keep patient safety at the forefront, right? How do we make sure that this doctor who's tending to all of these patients now in the real world as well as the virtual world, how do we minimize his chances of human error? How do we kind of give as much as patient context as possible while he's talking to these patients, is what we're going to see next in the demo. So what we have here on screen is, this is Dr. Board, and on the left is a patient, Diego, and this could be his mobile view, right? He could be having an application on his phone, and he could be a patient suffering from a chronic condition, right? And as his doctor, either reach out to me, for example, if I need to up with him, just say, hello, Diego. Obviously, this doctor is, an English-speaking doctor. Diego, not so much. All right. So what I did was, I sent him a message saying, hello, Diego. So it gets translated into real time here. If Diego's not so, good at typing, or, if he's, maybe he's, has a literacy thing, you can actually click on the message.
Hold on, Diego.
To listen to the digitized voice. So that's been taken care of by AWS Poly, right? You can also do a reverse speech to text as well. So the doctor could actually click this microphone icon here and speak into it. So that's just like the WhatsApp voice snippets that a lot of people use these days, and a lot of elderly people use it as well. They don't like typing. They prefer kind of a hybrid mix between the new way and old way of doing things. And I just kind of said all of that stuff. uh, and it translated it. So how are you feeling gets translated here. Um, so Diego says, I'm fine, but I have a terrible headache. So I go ahead and say, okay, have some aspirin. So what the system did is it did a real-time lookup on the EHR and does a real-time clinical decision intervention and says, no, you should not prescribe Diego an aspirin because he's actually on another drug that has a contraindication with aspirin, right? I just refreshed my page because the microphone was stuck. So what I can do is, okay, so I know he's allergic to, I know he has a contraindication with aspirin. So I says, okay, take some ibuprofen. So now the system says that Diego actually has a known allergy to ibuprofen. So I should suggest an alternative, right? As you can see, my message gets grayed out here. It doesn't actually get sent to the other side. So this is the patient safety aspect of the solution, right? So now I know I can't prescribe any of these. So I can ask him to take some Panadol, which is basically acetaminophen. So as you can see, that one gets sent. So what happens in this clinical decision support intervention flow is every message that I send gets read by AWS's Medical Comprehend service. So what AWS Medical Comprehend does is it makes sense of the message and kind of extracts the medical context and the medical terminology from there. So from there, it picks out that I uttered the word, the name of a medicine, ibuprofen, aspirin, Panadol, acetaminophen, whatever, and then kind of converts that to a standardized, e-prescription medication nomenclature, looks up the patient, the EHR that I'm integrated with, figures out if this is safe to prescribe to this patient, and then in real time will reply back to me, and tell me if this is safe to do it, or it'll just send the message on that side, or it'll give me an intervention. So this is just one use case where I can use technologies like these to make the patient provider communication as safe as possible. And you can think about other things also, like for example, I could ask the patient, hey, why don't you go for a run every morning, right? At that point in time, I can actually look up the EHR and say, oh, I shouldn't be doing this. This patient has a heart condition that could get worse if he does that, and I could show an intervention, right? I could make dietary suggestions, to which point I could look up food allergies and give real-time interventions. So the possibilities are endless. Eric, can you still hear me?
Yeah.
Yeah, awesome. So what we're envisioning doing with this is for this to be our kind of unified communication interface for patients and providers. We don't want doctors to be sifting through papers and files, or even through a clunky EHR while they're doing the job that they need to do, which is tend to patients. We want this to be the all-encompassing interface and build everything onto the chat interface, right? And chat interface have proven kind of success in other kind of areas, right? So take an example of WeChat in China. It's basically used for everything, right? People do their e-commerce, people do their each and every thing that we use websites and other applications for, they do everything on WeChat. So just kind of extrapolating from there on how us as humans are so akin to this kind of communication and this asynchronous way of doing things. If we can build an interface that kind of puts patient safety at the forefront, integrates with EHRs or CRMs, and brings all that patient context right at the forefront to the doctor, it will basically make it so much easier for when these things really take off, and doctors and other providers get really overwhelmed with this kind of tsunami of messages and transactions that are going to come their way, through these mechanisms.
Can you comment on the use of like user presence? I see you've got the little green circles there. Are those actively tracking like when a patient is online or offline?
Yeah, that's just that. I mean, that's the ubiquitous green dot that tells you when a patient is online.
Yeah.
So obviously all of the chat stuff, the real-time chat is powered by PubNub. That's the green dot is powered by the PubNub presence feature. And it's actually extremely simple to kind of build these kind of integrations when it comes to PubNub and AWS, because PubNub has something called blocks, which are these neat little serverless functions that you can create on the wire. So we basically don't need to have any box running. When we send a message, we send it to the PubNub data stream network. There's a PubNub function there running on a block that calls a bunch of AWS services to do all of this. Everything happens on the wire. There's no need to set up servers and databases and all those kinds of things. Everything is real time. It's super low latency, which is why it works so seamlessly. So that was a demo. Basically, like I said, we're using PubNub to power all the real-time features, and we're using these 4 AWS services, which are basically their machine learning powered services, i.e. Poly, to do the text to speech, transcribe medical, to do the speech to text, comprehend medical, to make sense of what's being said and extract the medical terms, and translate to do the real-time language translation.
Yeah. And you spoke a little bit about PubNub's use there, but to send the message, you're using just the pub sub, or I guess like what goes into the chat aspect there?
Yeah, the chat uses PubNub's core feature, which is PubSub, and then along with that, we're obviously using presence, and we're also using storage as well as blocks. So blocks is the key thing here, right? So how do you keep this super low latency? You do everything over the wire, and you use blocks to do the integration with all the AWS services.
Cool.
And all of this can be done and is done in a secure fashion, right? So everything is encrypted. There is authentication and authorization built in, to each channel. So every patient has their own dedicated communication channel with the doctor. So that takes care of their security and privacy. And as far as security over the wire, everything is over SSL, and there's an additional layer of encryption that is done with the PubNub provided keys, when we send messages.
Yeah. So Kabir, take it away.
Thanks, Joe. So yeah, that was a good kind of overview of all the technologies that we've used, and like Joe said, Medical Comprehend does medical terminology such as RX norm, such as ICD-10. So those are, RX norm basically is a standard for coding medications, prescriptions, and ICD codes are basically how diagnoses are coded. So those are two extremely useful kind of skills to have when you're building something like this. And then he also mentioned on how all of these services are HIPAA eligible. What that means is if you build them right, your solution can then be HIPAA compliant because the underlying technologies used are all HIPAA eligible. So that's the shared kind of responsibility model of these cloud services, and that's exactly how DocPod has been built. And what I didn't mention, while I was giving the demo, is that everything that we saw was basically just asynchronous text communication, right? And one of the barriers that obviously still exists is, especially in emerging economies, is internet bandwidth. So the same concept can very easily be implemented using plain old SMS text, right? You could set the same services up, and instead of the seamless chat interface that we have right now, it could just be two people texting each other, but you've got an integration in between that's doing all of the translation, and it's doing all of the clinical decision support intervention that we saw with the drug allergies and the contraindications and so on. The same tech can be used across geographies and demographics. Just breaking down barriers on who actually gets access to it. You can still use it on a dumb phone, and which I think is extremely valuable.
Yeah. So one question I have, to kind of underlie this is, why cognitive technology specifically? I mean, maybe it's implicit in what we've just seen, but I wonder if you can elaborate on the value of these things, like, automated EHR lookup and translate, like how they come together to do something that you couldn't do otherwise. Sure.
I mean, it's cognitive technologies actually that make something like this even possible, right? This is everything to do with human-centered solutions, right? While you can have these great big EHRs that you can put all of this data in, the reality is these solutions are clunky. Doctors typically have employed operators to use these EHRs because it takes up so much of their time. They obviously need to do something that's more valuable, which is take care of patients. So how do you do that? You give them something that that seems more natural. There's, I think, after voice, the next natural thing that everyone's become accustomed to is these kinds of chat interfaces, right? So you could basically build the same thing as an Alexa skill, and that would be amazing too. But then that also will then depend on how pervasive that hardware is as far as its distribution is concerned. Now everyone has a phone, everyone has SMS text, everyone has apps. Everyone is very accustomed to WhatsApps and iMessage and so on. So give them something that's that's human centric, that everyone is used to, feels natural. It doesn't have a learning curve, and that's where cognitive technologies come in, because you don't want to have these people work on complicated software and pull up records and menus and searches and so on. You want to have them enter normal language instructions, and sometimes not even that, right? Just kind of pick up on, it's almost like someone's eavesdropping on what you're saying and picking up and getting context from the patient record, and then giving those clinical decision support interventions, giving that extra context, and adding that layer of safety on top of that. So that's where the cognitive technologies really kind of add value to the whole interface.
Yeah, really cool. Well, thank you. I mean, I think that's a really nice place to wrap up.